So today, what we're going to do is that we have two goals. Number one, we're going to use Pythagorean theorem to solve problems, finding a missing side of a triangle, for example. And we're also going to prove Pythagorean theorem. Now, what's interesting about proving Pythagorean theorem is that there's probably 40 different proofs. Let's review simplifying radicals because that's something we're going to use quite a bit. So let's see here. Notice that I can split this one up to be 4 times 3. Then that splits up to be radical 4 times radical 3. And the square root of 4 is 2. And radical 3 is my answer. So 2 radical 3 is what radical 12 simplifies to. Alternatively, say for letter B here, we could split in anything we want. So for example, 6 and 10. Now the 6 reduces to 2 and 3. And 2 and 5. So now we begin to look for our repeats. So one of the 2's comes out. And notice 3 times 5 stays in, which is 15. So there is my simplified radical form there. So let's actually write out what the Pythagorean theorem is. But before we do that, we need to know some definitions. So number one, Pythagorean theorem only applies to right triangles. So we have to have a right angle. Now, the side opposite that is called the hypotenuse. Again, hypotenuse means to pull tightly, as if I pulled a string tightly to the ground and tied it down there. Now, the other two sides have names. They are called legs. So that's a leg. And that's a leg. And it actually doesn't matter which leg is which because they're just legs. So, this is how we say the Pythagorean theorem, but it's much easier to write it as an equation. It's quite beautiful, I think. Pythagorean theorem. In a right triangle, the sum of the measures, let's try that again. The sum of the squares of the lengths of the two legs is equal to the square of, you could say remaining side, or you could say the hypotenuse. It doesn't actually matter, of the length of the hypotenuse. Of the hypotenuse. And that one is red. Much easier to think about it as an equation. So, again, it never matters which leg you call A and which leg you call B. The important thing is that you call the hypotenuse C. So all we say is that when you have a right triangle, A squared, the square of one leg, plus the square of the other leg, the sum of the squares, is equal to the square of the remaining side. And that's it. A squared plus B squared equals C squared. We do need to know about what's called a Pythagorean triple, and I'll squeeze this in underneath. A Pythagorean triple is triple, clearly it's 3. So it's any 3 whole numbers, so no decimals, no fractions. It's just any 3 whole numbers that satisfy the Pythagorean theorem. That satisfy A squared plus B squared equals C squared. For example, 3, 4, and 5 are called a Pythagorean triple. Why? Because 3 squared plus 4 squared is equal to 5 squared. And just to walk through and finish it up to see that it's true, when you add 9 plus 16, you get 25. And 25 is 25. boom, there it goes. So we have a Pythagorean triple in 3, 4, 5. It turns out any multiple of that as well. So 6, 8, and 10, multiply by 3 to get 9, 12, and 15. And there are quite a few. In fact, there are an infinite number of Pythagorean triples, but not as many as there are numbers, ironically. The big skill that we're going to work through today is that we are going to find the unknown side length where appropriate, and we're going to simplify the answers that are radicals. So we're going to use our skills from yesterday to do that. And then we're going to see if they form a Pythagorean triple. So number 1, we're going to find a missing term, and then 2, identify. So let's look at the very, very first one here. The key is to always identify my hypotenuse. This is my C, because it is opposite that. So now these two are my legs. So when I have a squared plus b squared equals c squared, I'm going to substitute 6 squared plus 8 squared equals x squared. Now we start to simplify. The order of operations says that we need to square first, then add. So let me bring down a 36, bring down a 64, and bring down the x squared. My next step will be to combine those two to be 100 equals x squared. And then, of course, we have to remember, how do we get rid of a square? So what's the inverse of square? The inverse of square is called the square root. Square root. And one thing to consider is that in an equation, when you take the square root of both sides, technically there's a plus or a minus. So let me finish this up over here. The square root of x squared is x. The square root of 100 is 10. Now, practically speaking, when we come back here, notice what we cannot have. The answer is either positive 10 or negative 10. Since this is a distance, my official answer is that this has to be positive 10, not negative, because distance cannot be negative. And now to answer the second part on letter D, the question is this a Pythagorean triple, 6, 8, and 10? And the answer is yes, because 6, 8, and 10 are all whole numbers. Is a Pythagorean triple. So 2 answers. Number 1 is that x is 10, and 2, this is a Pythagorean triple. All right, on the next one, letter E, we have to always pay attention. Here's my right angle, so opposite that is my hypotenuse. So that's C. So when we start with our handy-dandy super secret equation, a squared plus b squared equals c squared, then we are going to substitute things in. It doesn't matter which one is a and which one is b. So I'm going to put 5 squared there for no particular reason, x squared there, and substitute in the 13 for c. Now, order of operations says I need to get rid of my squares first, or evaluate my squares. So this one becomes a 25. X squared is x squared, and I have 169, 169. Now, to get x by itself, I have to subtract 25 from both sides. So now I have x squared equals 144. Now, when I square root both sides, don't forget that there is a plus or a minus in the front. My x is plus or minus 12. And clearly, because I cannot have a negative distance, my value here of x has to be 12. So that's my answer, positive 12. And the next part is my 3 numbers. I have a 5, a 12, and a 13. So that means I do have a Pythagorean triple.